Bang! The surprising spark, the moment that ignites curiosity and innovation. You wouldn't think fireworks and Ferraris have much in common, would you? They seem worlds apart, one a symbol of celebration and the other of speed and engineering prowess. But believe it or not, the invention that lights up our skies also played a part in putting the world on wheels. The connection is more profound than it appears at first glance. Gunpowder, the stuff of booms and bangs, sparked the very first inklings of the internal combustion engine. This explosive material was more than just a tool for destruction, it was a catalyst for progress. Way back in the 17th century, a clever chap named Christian Huygens figured out how to make gunpowder go boom inside a cylinder, pushing a piston. His ingenuity laid the groundwork for future innovations. It wasn't exactly a smooth ride, but his explosive experiment planted the seed for the engines we know and love today. The journey from Huygens' rudimentary designs to modern engines was long and arduous. Now you might be thinking, gunpowder in my engine? That sounds a bit dodgy. And you'd be right. The idea seems almost absurd by today's standards. That sounds a bit dodgy. And you'd be right. It was noisy, inefficient, and frankly terrifying. The early attempts were far from perfect. It was noisy, inefficient, and frankly terrifying, but it proved a point. You could create motion from controlled explosions. This was a revolutionary concept at the time, but it proved a point. You could create motion from controlled explosions. This principle became the cornerstone of engine development. This breakthrough set the stage for centuries of tinkering and toiling, a quest to find a safer, more reliable way to harness energy and make vehicles move. Inventors and engineers across generations built upon this foundation. Little did Huygens know, his explosive experiments were the first wobbly steps on the road to the automobile. His work was the spark that ignited a revolution in transportation. While Huygens was playing with gunpowder, others were experimenting with a different kind of power steam. In 1769, a French fellow named Nicolas Joseph Cugnot unveiled his masterpiece, a massive steam-powered tricycle designed to haul cannons. Imagine a giant tea kettle on wheels puffing and chugging its way down the road. That was Cugnot's baby. Cugnot's contraption was slow, cumbersome, and prone to the occasional boiler explosion. Not exactly ideal for a Sunday drive. However, it marked a pivotal moment. For the first time, a self-propelled vehicle powered by an engine turned a wheel on public roads. It was a clunky, awkward first step, but a step nonetheless towards the future of transportation. The quest for a better engine continued, driven by the relentless pursuit of efficiency and power. Inventors knew that steam, while powerful, was bulky and inefficient. The massive boilers and complex mechanisms made steam engines cumbersome and difficult to manage. They needed something lighter, something more compact, something, well, more explosive. The search was on for a new kind of power source that could revolutionize transportation and machinery. Enter the internal combustion engine, fueled by flammable gases. This innovation promised a more efficient and manageable power source. In the early 19th century, Swiss inventor François-Isaac de Rivaz designed an engine that ran on, wait for it, hydrogen. This was a groundbreaking concept at the time. His hydrogen-powered car was a bit rough around the edges, but it proved that internal combustion could be a viable option. It was a significant step forward in engine technology. Then came along Étienne Lenoir, a French engineer who took the concept a step further. He saw the potential in internal combustion and sought to improve upon it. He ditched the hydrogen and developed an engine that ran on coal gas, a far more practical fuel source at the time. This made the engine more accessible and easier to use. His engine, while still quite rough, powered a three-wheeled vehicle that could actually cover some distance. This was a remarkable achievement in the evolution of motorized transport. The age of steam was coming to an end, and a new era, powered by the controlled explosions of internal combustion, was dawning. This marked the beginning of a technological revolution that would change the world forever. Now, let's talk about the big leagues, the fellas who really put the motor in motorcar. Step forward, German duo Carl Benz and Gottlieb Daimler. These two engineering giants, working separately but with a shared vision, revolutionized the world of transportation. In 1886, Carl Benz unveiled his patent motor wagon. This wasn't just a carriage with an engine slapped on. It was a purpose-built, three-wheeled vehicle designed from the ground up for motorized transport. Around the same time, Daimler, in partnership with his brilliant colleague Wilhelm Maybach, was busy crafting his own masterpiece. Their creation, the Reitwagen, was essentially a motorized bicycle. but it boasted a groundbreaking feature, the first four-stroke petrol engine. This engine, refined and improved by Maybach, would become the template for virtually every petrol engine to follow. These German pioneers didn't just invent the motor car, they birthed an industry. Section 5. Across the pond, America takes the wheel. While the Germans were busy inventing the automobile, the Americans were busy figuring out how to mass-produce it. Enter the Duryea brothers, Charles and Frank, bicycle mechanics with a dream of building a car for the masses. In 1893, they unveiled their creation, the first successful gasoline-powered car built in America. But it was Henry Ford, a man with a vision of democratizing the automobile, who truly revolutionized car manufacturing. In 1908, he introduced the Model T, a car designed to be affordable, reliable, and easy to maintain. To build his car for the great multitude, Ford implemented a revolutionary new system, the assembly line. This innovation, inspired by the meatpacking industry, allowed Ford to churn out Model Ts at an unprecedented rate, driving down costs and making car ownership a reality for millions. Section 6. From workshops to factories, the rise of mass production. Before Ford's assembly line revolution, cars were essentially hand-built, crafted one at a time in small workshops. The process was slow, expensive, and reserved for the wealthy elite. Ford's genius lay in breaking down the manufacturing process into a series of simple, repeatable tasks. Each worker on his assembly line was responsible for a single specific job, like attaching a wheel or tightening a bolt. This division of labor, combined with standardized parts, allowed Ford to build cars faster, cheaper, and more efficiently than anyone had imagined possible. The assembly line wasn't just a technological innovation, it was a social and economic revolution. It transformed the automobile from a luxury item into a mass-market product, forever changing the landscape of transportation. Section 7. Setting the standard, the French connection. While the Americans were focused on mass production, the French were busy refining the design and layout of the automobile. In the early days of motoring, cars were a bit of a hodgepodge, with engines placed haphazardly and controls scattered about. It was the French, with their flair for design and elegance, who began to standardize the layout of the car as we know it today. They established the Système Panhard, which placed the engine at the front, driving the rear wheels through a gearbox and driveshaft. This layout, known as front-engine rear-wheel drive, became the industry standard for decades to come. They also pioneered the use of the steering wheel, pedals for acceleration and braking, and the gear lever, all innovations that made cars more intuitive and enjoyable to drive. The French, in their pursuit of automotive chic, inadvertently shaped the future of car design. Section 8. The Road Ahead, a century of innovation and beyond. From those early sputtering experiments with gunpowder and steam, the journey of the automobile began. Over the decades, we've seen the car evolve from a simple mechanical curiosity to the sleek, sophisticated machines of today. The car has come a long way. The 20th century witnessed an explosion of innovation in engine technology, safety features, and design. Each decade brought new advancements, pushing the boundaries of what was possible. We've seen the rise of the sports car, capturing the imagination of speed enthusiasts around the world. The SUV, dominating both urban and rugged terrains. The minivan, becoming a symbol of family life, and everything in between. But the journey is far from over. The automotive industry continues to innovate, pushing the envelope of what's possible. The automotive industry is on the cusp of another revolution, driven by concerns about climate change and the need for sustainable transportation. Renewable energy sources are becoming integral to this transformation. Electric cars, once a niche oddity, are rapidly becoming mainstream. They represent a significant shift towards cleaner, more efficient energy use. Autonomous driving technology, once the stuff of science fiction, is becoming a reality. These advancements promise to redefine our relationship with driving. The future of the car is electric, autonomous, and more connected than ever before. Cars will communicate with each other and with the infrastructure around them, creating a seamless driving experience. As we hurtle towards this exciting new era, it's worth remembering the pioneers, the tinkerers, the visionaries, the dreamers who paved the way. Their relentless pursuit of innovation laid the foundation for the marvels we see today. From those first explosive steps with gunpowder and steam, to the cutting-edge innovations of today, the story of the car is a testament to human ingenuity and our unquenchable thirst for exploration. The road ahead promises even more exciting developments as we continue to push the boundaries of what's possible.